There we go. That's better. All right. Welcome, everybody, to Engineering 213. I was saying this earlier. Usually, Engineering 213 is one of the earliest classes that I teach, but because I taught CAD last semester, I know quite a few of you. But for those of you that don't know me or tried to block everything in Engineering 102 out of your heads because of how horrible it was. That's a joke I write mine. I'm Dr. Michelson. I'm going to be your instructor for the first part of a 2-semester course in engineering mechanics, namely statics. What we're going to be doing today is just going through how the class is operated, kind of what we're going to be covering in here, why you're taking the class and whatnot. I'm going to spend the first part of the class just going through the class logistics and whatnot. I'm going to break a little bit of a rule of PowerPoint, and that's show you my best picture first. So a little bit about me. So in addition to being the instructor for the class, I am the college's associate dean. So that means if you ever have any academic related issues, I sort of manage the academic side of things here in the unit. So if you ever have any questions about degree works, about anything in your classes, anything like that, come see me. That's what I'm here to do. I'm here in the dean's office. That's one floor up, and it's literally right there. I'm pretty much always available if I'm not in class and whatnot. I'm around, so I do tend to run around solving a lot of problems though. So if you need to get a hold of me, maybe let me know you're coming in advance. But I'm usually around. There's my phone number and my email address. It's also in the syllabus as well. That is my daughter Stephanie. She was supposed to stay a baby, and she didn't. She just kept getting bigger. In this situation, she is certainly not in a static situation. She's dynamic because she's moving. She's on a bike. But you'll get that joke a little bit later. I did have to teach her how to start preparing invoices this summer, though, because she started to lose a couple teeth. So that's, again, a joke. Fun. That's my daughter, Stephanie. That's my wife, Becky, and that's Stephanie, earlier beta version of Stephanie. So now we got some laughs. Okay, there we go. I got my PhD from WVU. I'm a registered professional engineer here in the state of West Virginia. And I'm a civil engineer by training, so you biomedicals and mechanicals don't hold that against me. But my area of expertise is structural engineering, and particularly bridges. Bridges, as we all hope, are structures that kind of sit still. And so since statics is a science about systems in equilibrium, this is definitely well within my wheelhouse. But what I tend to focus on predominantly is short span steel bridge design. These are a couple of the projects and whatnot that I've worked on, in my career. But my stuff primarily sits still, and since that's a lot of what we're going to be talking about this semester, this is a class very near and dear to my heart to teach. Okay, let's talk about the course overview. Let's talk about how the class is going to be organized. So here's the grade breakdown. Okay, let's talk big picture, and then we'll narrow into the details. Okay, attendance in the class is worth 10%. This is definitely one of the most important engineering classes that you take. And so I really want everybody here. So attendance, I'm going to collect that with the QR code here in a bit, like I've done in previous classes. But that's going to be worth 10%. The single biggest component of your grade, like the single component, is the homework. This is definitely a class where doing matters, okay? So I wanted the homework to be worth quite a bit. There are 4 exams in the class, but if you recall, we don't have exams in college. We have celebrations of learning. So we're going to be celebrating 4 times this semester, 3 of them during the semester, and then the last one is during the final exam slot during finals week. And I will go ahead and tell you that I am normally not one to have a comprehensive final unless it makes sense, and it does make sense in this class. But you'll see what I mean when we start whittling it down to the end, that a comprehensive final is not the biggest deal in this world or in this class, because this class is definitely one where the material builds on itself. So it works out very well for this class. This is our textbook. Most of the homework assignments are coming out of this, but I'm not going to micromanage you. I don't care if you get a physical copy or a digital copy, doesn't matter to me, however you want to do it. We are starting to get to the point in engineering. I mean, you all want to be engineers, and statics and dynamics is, they are two of the most important classes you'll take as engineers. Not to sound dramatic or anything about it, but I do think it's a good idea to have a statics and dynamics reference. So I'll leave that on the table. Again, I don't care how you get it, but it's not a bad idea to have that on hand, like throughout your career. Okay, so far so good? Okay, let's talk about the course operation. So technology, when it comes to the tools that we're going to use in the class, so one thing I'll tell you is that I see a lot of you have laptops here, like for jotting down notes and whatnot. That's fine. You can use a laptop or tablet. This is not going to be like 102, like CAD, where like you need a laptop to come to class. The best way of describing this class to put you into the mindset of what this class is like is applied physics. That's kind of what this class is. So it's like a physics class. So it's not like 102 where we're doing software and things like that. So if you want to use a laptop or tablet or something like that, that's completely fine. But that's fine. Notebook's fine. Whatever. We're not going to need that in class. We are going to use Blackboard though. I use Blackboard pretty heavily. If you've had me for class before, you know what I'm talking about. I post all the homeworks, the lecture notes, the grades, all that stuff's on Blackboard. I'm going to pull Blackboard up here in a little bit. You're also going to be submitting your homework via Blackboard. And so what that's going to mean is I'm going to give you a problem, you do the problem, upload the scan of the solution. So if you want to do it by hand and then scan it using something like Cam Scanner or Microsoft Lens, that's fine. I see some of you have tablets, and I know there's apps where you can just do the problem and then turn it into a PDF and upload that. That's fine too. I'm no problem either way. As my general rule, as long as it's neat and easy to discern, I'm fine. I'm not. Either one works. But like I said, in terms of the needs for this class, it's completely the opposite of 102. It's pretty basic. Okay. So far, so good. All right. Teams and OneNote. So I use email and Teams as means of communicating with the students. I will use Teams for communication really for two reasons. The first is if we have, like a tornado hit the town and we have, class that gets canceled, it's really easy for me to send a note to the class, say, hey, something's up, so we're going to have to cancel something. So Teams is a very fast way of doing that. The other reason that I'll use Teams is for homework help. So for example, we're going to have pretty regular homework assignments in the class, and every now and then we might have a tricky problem, and you'll ask me a question, and I give you an answer, but I think that answer is something everybody needs to hear. So I'll just post it on the Teams channel so that everybody can see it, because it's kind of quick, Because of the frequency of homework assignments in here, we'll talk about that here in a bit, it's a lot of times pretty convenient to just send a note out to the class pretty quickly on Teams than it is via email. That doesn't mean I won't use email to communicate with the class. Anything that's more formal or less time sensitive, I'll probably just send an email out. So the big thing for you all is to just make sure that you're checking your email periodically and checking Teams periodically. You should be good. Inside the Teams channel, there is a OneNote. I actually tried to activate it yesterday and I was getting some IT hiccups on that. But once that gets fired up, I'm going to use the OneNote for all of the board work in the class. So instead of doing problems on the board, I'm going to do it inside OneNote. The value for that is that way it's accessible to you all 24 hours a day, 7 days a week. You can access it at any time. And unlike Engineering 102, there's going to be a lot of stuff on the board in this class. Because again, it's like an applied physics class. So there's a lot of example problems, a lot of calculations. So I've been doing this for a little while using the OneNote, and everybody seems to universally like it. So beyond that, not much else really needed for technology other than for attendance. So let's pull that up real quick. So I'm going to collect attendance with these. If you've had me for Engineering 102, you know the deal. So this QR code will take you to a Google form where you just put your first and last name in, hit submit, and that's how I take attendance. So it's a lot faster than some sign-in sheet or anything like that. It's a lot easier to follow. What I will do, so this first lecture was the only day I didn't do this, but what I'll do is, this is my announcement slide. So I'll start class every day with this announcement slide, and it'll have a QR code here in the corner. You come in, scan the code, I'll go through some basic announcements, and then we'll sort of go through what we're going to talk about today. Speaking of, like, my announcement for today is my office hours. So I'm around pretty much, quite a bit, as AD. So my office hours, my daughter's in kindergarten, so I got to pick her up after 2:30, 3 o'clock. So my office hours, I have my office hours every day from 12:30 to 2:30. That doesn't mean that if you need something and you need to get a hold of me outside those office hours, you can't. Just let me know. The only thing that might be worth mentioning is I teach Monday, Wednesday, Friday, but I don't teach Tuesday, Thursday. So there might be a Tuesday, Thursday here and there where I come in a little late. But that doesn't mean I'm not accessible if needed. Okay? So far, so good? Okay. Any questions? All right. Let's go back here. All right. So attendance. So this is how I collect the attendance, and I'll upload the attendance grades to Blackboard pretty regularly. I usually do full attendance grade if you're here on time, half attendance if you're late. Obviously, you don't get the attendance grade if you're not there that day, but it'll obviously be excused if you have an excused absence and whatnot. The other thing that's worth mentioning is the fact that I've got this little podcast microphone right here. It's picking up my voice. I'm recording everything that's on the screen and everything that's on audio right now, and that's getting uploaded to a YouTube playlist once the recording processes. So if you go to Blackboard, and I'll pull Blackboard up here in a second, there's a link for a YouTube playlist, and I'll upload the lectures to that YouTube playlist after every course. It might not be immediately posted, like give me a couple hours and whatnot to do it, but my goal is after every lecture to have that curated, and the link is right there on Blackboard, so you don't have to manage a bunch of different links. It's all there. I've been doing this for a little while, and this is another thing that I found students really like, especially in a class like this where it's really calculation heavy and whatnot. So far, so good? All right. Now, let's talk about the homework, because I do the homework in this class a little differently than probably you're expecting from some of your other professors. And I'm going to start off, which is probably the most alarming thing, and then tell you why it's not so alarming. So I do a homework assignment after every lecture. Do the following lecture. And some of you are thinking, are you kidding me? That's crazy. Well, I'll tell you a couple things about it. So first off, the homework assignments that we do in here are markedly short, okay? So if you had a professor that did homework every week, I do the same amount of work, just spread out more. So you'll see after this first assignment, we don't have a homework assignment today, but we'll have one Wednesday through Friday. You'll see what I mean in terms of the length of the assignment, because it's pretty short, okay? But there are a couple of marked advantages to doing homework this way. The first is that the homeworks are really short. They're not very long. There are a couple assignments that are kind of long, and I give you another lecture to do it, but for the most part, the homeworks are really manageable. I don't think I have very many assignments that would take you more than an hour. Most of them are going to take you in the neighborhood of 20, 30 minutes. They're really not that long. One of the other advantages is that the homeworks are really built based off of the content of that lecture. So you really don't have a scenario where a professor assigns a homework that's due in 2 weeks and it's the day before the assignment's due and you got to remember what you talked about 2 weeks ago. That really doesn't happen, because the homework is such an immediate assignment right after what we talked about that everything that you're doing on the assignment's really fresh in your head. And then the other thing that's worth mentioning is that because there are so many of them, each one is a pretty low stress endeavor. Like if we had this class and there were 5 homework assignments, each one of those homework assignments would be important, right? But where there are so many of them, each one really isn't that big of a deal. You know what I mean? So like I've had students that get A's in the class and they miss an assignment here and there. There's no big deal. Stuff happens. Now, if you miss 20 assignments, well, that's a little bit of a problem. But doing it this way, like when I first started doing, I started doing it during COVID because I said, okay, if we're going to be on Monday, Wednesday, Friday at 10 o'clock, I need a means of guaranteeing that everybody's paying attention. So I started doing this regular homework assignment thing because I thought now they have a reason to log on, because they'll log on, they'll listen to what I say, and then they got to do the work for the next lecture. And I thought I was going to get torn apart in my course emails. I really did. But I was surprised how much students liked it because they said it's a nice change of pace from their other classes. Nobody else really does this, and it's pretty like it's a pretty smooth endeavor at the end. And you'll see what I've done for pre-finals week or dead week, and you'll see it. I had a point to all of this. So the homework will be assigned like during the lecture. So we meet Monday, Wednesday, Friday at 11 o'clock. So the homework, it'll show up at 12 p.m., like right after, and then it'll be due the following 11 p.m. So the only time that there's not a homework assignment is when you're in class, right? So it makes it pretty easy to manage. In terms of the format, again, I'm pretty loose on format, especially since I'm doing so many individual assignments. But my big thing is that as long as the homework is neat and legible, that's what matters. Maybe put, your name and course, like Engineering 213 up top, like pagination, like page 1 out of 2, 2 out of 2. I don't think you're going to have very many assignments that take more than one page, just because there's so many of them. I think you'll see once we start getting into the pace that the homework, while it seems scary that there's one every day, it's actually pretty manageable. If you think about it like this, you have one class where you do the assignment for 20 minutes and then you're done. It's like a way of just checking that box off in your head. So, I will accept late work. It's a 20% late penalty, but I won't accept work either after it's graded or after the solution's posted. Because if the solution's posted, then you have the answer, right? Because then you could just do it, So, but again, because there's so many of them, I found it's really not that big of a deal. Okay, exams. Again, we don't have exams in college. We have celebrations of learning. We're going to be celebrating 4 times this semester. 3 of them will be during the semester. The 4th and final exam will be during the final exam slot. Okay. We got somewhat lucky. Our exam's on Tuesday of finals week, so we don't have to wait to the very end. The first 3 exams are not intended to be comprehensive. In other words, exam 1 is on particle statics, exam 2 is on rigid body statics, exam 3 is on applications. Like they're not intended to be comprehensive, but some of the material does bleed over. Like it does carry over from exam to exam, because this is a physics class. It's an applied physics class. Because there's going to be some stuff that's just common, but that's not my intent for the first 3 exams. The 4th one is comprehensive, but you'll see what I've done in the course schedule to sort of allay any concerns that you have. The exams are not intended to be time critical. Okay. When I was a student, when I became a professor, I said, when I wanted to develop like how I'm going to approach classes, I said, I'm going to make a list of all the stuff that professors used to do that annoyed me when I was a student. I said, I'm not going to do that, okay? And one of the things that annoyed me is when a professor gave me an exam that took 4 hours to complete and said you had 50 minutes. Like, that stopped becoming a test of my abilities in the class, and it started becoming an exercise of how fast I could write numbers and how fast I could hit buttons on the calculator. That's not an examination of my understanding of engineering mechanics. So I use a rule of 3, and the idea behind that is I will make the exam and then I will take the exam. And if I can do a problem in 10 minutes, you can do it in 30 minutes, right? So I will actually time the exam. In fact, you know how like you'll take an exam and this problem will be worth 20 points and this problem will be worth 30 points? Or how did he figure out? It's how long it took me to do them. It's that simple. That's how I do it. I time it. I basically have like a little timer and I'll weight the times. It's like lap times, and that's how much each problem's worth. My easiest way of making the problems fair. So that's how I do it. So I just wanted to throw that out there. Okay. All right. Any questions so far? Okay. Let me pull up the actual syllabus and the Blackboard shelf so you all can see that, and then we'll talk a little bit about the class. Whoop. Okay. So first off, here's the syllabus. Again, nothing here, and this is on Blackboard, by the way, nothing here that you haven't already seen, maybe some more details, but here we've got the organization of the class, the grade breakdown, same as we did before. So I'll get into the specifics of when I said two-part class. This is essentially like a two-part class. We're in statics. Next semester you'll take dynamics. I mean, use the same textbook. But really in this class, we deal with any condition where the body is either at rest or at a constant velocity. That's what a static situation is. A dynamic situation is when a body is undergoing an acceleration. So that's how we split it up into statics and dynamics. But I'll get to that here in a bit. Okay. Again, communication policy, I've talked about all that, what email and Teams. Technology, again, technology in here is going to be pretty minimal. Attendance policy, I've talked about that. The homework policy and what the formatting should look like on the homework submissions. The exams, student outcomes, we'll cover that here in a bit. Honor and academic policy, and I'll say one thing about ChatGPT. I don't think it would help in this class. I'll just say this. I asked ChatGPT once. I gave ChatGPT like 6 numbers, and I said, compute the standard deviation of these 6 numbers, and it was wrong. So if you want to use it. I don't think it would help, in here. You'll see what I mean. Like this class is a very visual class. I'm going to give you a situation with some ropes and pulleys and tell me the tension in this rope. It's not really something you can ask ChatGPT to do. It doesn't really work like that. So, so that's why, like, there's actually a series of generative AI policies that you can use at Marshall. And mine's actually the loosest. Like, use it if you want, just at your own peril. So that's all I would say. Let's see. Okay, this is what I wanted to focus on for the most part. This is our class schedule. Okay. So if you notice, for every one of the exams, there is an exam review day and then the exam, okay? So the way that it works is I'll come in during exam review day. I will talk about the format of the exam so you'll understand like how many questions you're going to get, what the question, the topics that are going to be covered on the exam. I am not one, I'm very hyper aware, like this exam is not going to cover any of this stuff. It's not going to, it will cover what we've talked about. And I've taught this class a number of times, like we will follow that schedule pretty religiously this semester. In terms of where we're at on things. I'll admit, this October break, y'all are aware of this October break now? So I'll admit, this kind of like messed up the schedule a little bit. We're going to get to rigid body equilibrium. These problems are kind of long. They're not hard. There's a lot of steps to them. So I'm going to give you an assignment on this Wednesday, but it's not going to be due to the following Wednesday because we're going to need to come back from the October break and sort of look at it again. It's going to take a while to get through it. But instead of having a homework due right when you come back from the break, we'll come back, have a homework due the following day. So you actually get a break. I know, it's crazy, right? But in terms of the exam dates, the exams are when they are. So Monday, September 16th, that's going to be our first exam. Friday, October 18th, that's going to be our second exam. The third exam is going to be Friday, November 15th, and then we have our final. So I don't know if y'all knew this, but in addition to this October break, they made the semester a week longer, right? So last couple of years when I taught statics, we would have this exam we'd have the exam review on Monday, we'd have the exam on Wednesday, and then Friday I would cancel class and y'all could have an early Thanksgiving break. We have another week, right? So this is sort of like what I decided to do with the extra week. So I added a topic in structural analysis, which I think we're going to cover cables, because I never really covered cables in a prior class. I am still going to do that makeup day that day before Thanksgiving break. So we'll have 2 lectures on friction, Monday and Wednesday. I'm calling this a makeup day. Basically, I will use that makeup day if we get hit by a tornado or a volcano explodes on Buskirk, you know. Otherwise, we will just plan to not have class on Friday, October 22nd. So this is Thanksgiving break, so the Friday before Thanksgiving break, we'll just cancel class. When we come back, what we're going to do during pre-finals week is a full-blown start-to-finish review of the class. So just problems. That's all we're going to do is example problems. And take a look at what's going on right here. No assigned homework during that week. So I'm giving you all a break. So we just come in, do problems. If the final's going to be comprehensive, we'll make that time as useful for you as possible by just coming in and doing examples. Because again, it's like an applied physics class. So you know how it is if you've had a class like that. Just doing problems will make the exams go a lot smoother. So that's what we're going to do. Does that sound like a plan? So that's what we're going to do with that extra week. Because honestly, like, if you go through the textbook, we pretty much cover everything that there is in the textbook, barring a couple topics through the first half of it. So I don't really need the other week. So we'll just review. So sound good? All right. Blackboard. Let me pull up Blackboard real quick. So here is the course shell for Blackboard. You'll know you're in the right shell because you'll see the connects. I tried to come up with a good picture for statics. It kind of made sense. Either that or Legos or something. Right now, you're not going to see much. You'll see the course syllabus, which you can access here. This will take you to the YouTube playlist. If you open up lecture notes and supplements, you'll see a series of topics. I don't have many of them right now. Bless you. I don't have many of them right now, but as the semester progresses, you'll see more and more notes get added, and they'll all be added here. And then the homework assignments will be sort of put under here. I'll sort of stack them down. As assignments will get graded, I have like an older homework assignments folder that I'll move them into so that the page doesn't get cluttered. But you'll see everything right here in this one area. And then if you click Gradebook, you'll see that I've already got a lot of the main grade sections for the class figured out, and then your overall current grade will be right there. So, sound good? Okay. All right. The only other thing I wanted to discuss before I call it for today is why you're in this class. And I could give you a cheap answer and say, well, because the degree says you have to have it, so that's why you're taking it. But that's a cheap answer. And really what I want you to know is really why does this class matter? I'm curious about something. Is there anybody here that has either a friend, a sibling, a parent who is an engineer? Okay. Have any of them ever mentioned statics to you before? You ought to ask them about statics if they haven't. Most of them will have a statement similar to the one I'm about to say about statics. And they'll say that statics is when I first started to feel like I was an engineer. Most of them will say that. Because it started to get kind of real in this class. It's your first year in college, and you take CAD, and you take the spaghetti bridge class, and you take your calculus and your physics, and it's cool, it's fun, And those classes are important for a number of reasons. I mean, I'm sure that a lot of you developed, like your social networks and got to learn what it's like to be at Marshall. But now it's time to actually start talking about engineering. And I think most engineers sort of come back to statics and they go, yeah, that's when it got real, okay? Let's start at square one, okay? Let's just start at basics, okay? What is physics, okay? I say that that's square one because, we are in engineering, and I think most of you could probably give me a pretty cogent definition for what engineering is. I usually tell, like when a high school student comes up to me and they are asking what actually is engineering, I say I could give you a long-winded definition, but the short answer is we solve problems. And the only difference between a civil engineer, a mechanical engineer, a biomedical engineer, we just solve different problems. Basically it, right? But how do we solve those problems? We use math, we use physics, we use principles of science and common sense to come up with real world solutions. So starting at square one and saying what is physics, well, that's one of our fundamental tools that we as engineers use. So what is physics? Well, I could give you a long-winded definition. This is about the shortest definition that I think I could come up with. I think that we would all probably agree with this definition. What is physics? It's the study of matter, energy, and their interaction. Pretty basic, right? Okay. Now, physics is a really, really big field, and there are a lot of subdisciplines in physics. There's solid state physics, and nuclear physics, and quantum physics, and particle physics, right? One of the fundamental subdisciplines in physics is mechanics, okay? So here's physics, okay? That's a big starting square one question. What's mechanics? Okay, now we're getting a little bit more detail. What is mechanics? Well, mechanics is the branch of physics, the area of physics that deals with forces, particularly whenever we have some system that's being subjected to forces, okay? And we might have we are going to have a later discussion about what actually is a force. I've got a couple different definitions for what a force is beyond just F equals ma. There's a number of different ways of thinking about it, okay? Especially when we start introducing the concept of the moment, which we'll talk about later. Now, this is a course in engineering mechanics. That's what this class is. So we're obviously going to need to understand basically what is mechanics. Mechanics is pretty closely related to physics. We're going to build off some of these basic concepts in physics. In fact, that's what I'm going to be talking about on Wednesday is what are the three laws and universal gravitation and all that jazz. Now, I want to delve into mechanics a little bit. I mean, if you look at the cover of your textbook, the name of the textbook is Vector Mechanics for Engineers. And that term vector is going to be something we spend a lot of time talking about this semester, because vectors are mathematical objects which we are going to find very, very useful this semester. All right. So when we look at mechanics, when we, as engineers, look at mechanics, we're going to need to look at two different areas, okay? The first area is the media which is being studied, okay? And what I mean by that are things like rigid bodies. So rigid bodies are those that we as engineers have assumed that they will not deform under applied load, that they are infinitely rigid. You take this battery cover here, I apply a load, we're going to assume it's infinitely rigid and that it's not flexing any. Now that's not really ever true, but for the purposes of an analytical model, it is often close enough for the purposes of conducting an analysis. Sometimes it is, sometimes it's not, so we will also consider deformable bodies. So in other words, in our analytical model, rigid bodies are assumed not to deform, whereas deformable bodies, we recognize that they do. Okay? You are in Engineering 213, which is statics. Later, you will take Engineering 216. What is the title of Engineering 216? Mechanics of Deformable Bodies, right? You biomedicals take BME 302, but same idea. Okay? There's also a third media, which is important, fluids. Okay? Fluids being gases or liquids. So what we're primarily going to be talking about in here is rigid body mechanics of solids, solid physical systems. Okay? So that's one thing we need to look at is the media in which we're studying, but then we also need to look at the condition of the problem at hand. And so we have two conditions that we break mechanical problems into. We have static conditions and dynamic conditions. Static conditions are any time the body is at rest or at a constant velocity, or dynamics are any time we're dealing with a body that is undergoing an acceleration. And so we're going to focus this semester primarily on bodies that are at rest or at constant velocity. Okay? There are tools in statics that we will learn that will be broadly applicable across the board. I'll give you an example. Whether the body is at rest or at a constant velocity, one of the applications of the science that we're going to learn in here is the ability to compute the location of a centroid. Now, you've probably never heard the term centroid, but you probably have heard the term center of gravity, right? Everybody's heard the term center of gravity. Well, being able to accurately locate a center of gravity is something we're going to learn in this class, okay? And that's going to be applicable, I don't care what body you're talking about, what area you're talking about. So that's something we're going to focus on in here quite a bit. Okay, so if we were to categorize mechanics and look at the curricula of classes here at Marshall, right now we're here, okay? That's what we're doing in here, rigid body statics, okay? So we're not going to consider deformations, okay? We will, you will consider deformations later, just not now, okay? This is one of those you got to walk before you can run kind of things, okay? And you can't really assess deformations without understanding rigid body mechanics first. So we're going to start here with rigid body statics in Engineering 213. And the next semester, you're going to take rigid body dynamics, Engineering 214. Okay, so that's really what we'll talk about with rigid bodies. Now, if we get into deformable bodies land, we can either talk about mechanics of deformable bodies. Sometimes it's called strength of materials. That's when we have static situations where we consider their ability to bend. The dynamics of deformable bodies has a very specific name, and that name is vibrations. So anytime you have a structure that vibrates, that's really what we're talking about. Whenever, from a physics perspective, what is the study of vibrations? It is the study of dynamics of bodies that deform, okay? And you would be surprised how many applications there are. I spent quite a bit of time studying mechanical vibrations in grad school. And some of you might think, well, why would a civil engineer care about mechanical vibrations? One word for you, earthquakes. That's what an earthquake is. It is a mechanical vibration induced on a building. So it's the same idea, Fluids, we cover statics and dynamics and fluids all in one class. It's just the nature of the beast. So by the time it's all said and done, you all will be exposed to all of this. This one probably the lightest because you got to really roll up your sleeves on that. For the most part, you all will be exposed to all of this. Okay. All right. Let me take a step back. Does anybody have any questions about what we're doing, why we're doing it? Okay. I did forget something since we're on the topic of this being an applied physics class. Let's talk about calculators. I really don't care what type of calculator that you use, okay? I don't want that calculator to have a Wi-Fi connection, but beyond that, in other words, like your cell phone, but beyond that, I don't care what calculator you use. If you are interested in taking the Fundamentals of Engineering exam, the first step towards getting your license, I would suggest an FE compliant calculator, but I'm not going to police you one way or another. If you are a fan of your, TI Inspire, TI 89, or your graphing calculator, whatever you got, that's fine. I don't care. You can use whatever you want. You do need one though. Okay, I will say that. So tests, calculators, please use them. Please bring them. I am not one of those professors who says, no, you must use a pencil and be able to multiply 23 times 47 in your head like that. I don't care about that. Bring a calculator. Please bring a calculator. Bring a calculator, bring a pencil, bring maybe a straight edge because it would help. But yeah, you are more than welcome to use calculators in here. So I would bring them to class regularly as we're going to be doing a lot of example problems together in class. So I did forget that, but I should mention it. Any questions? Everybody excited? Good. This is going to be a fun class. All right. I'm going to pull up the QR code one more time in case anybody did not get the chance to grab it. With that, that's all I have, everybody. We're ending a little bit early, but we're going to start at square one with physics on Wednesday. So that's all we got.